Hello everyone, and welcome back to our introduction to Kotlin. We're looking at the Kotlin syntax still. This is our part 1.3. So just to recap, in previous sections we've looked at these basic types, our local variables. So we looked at val and var and the differences between them. We looked at functions. We talked a little bit about control flow. So we looked at our if, when, for, and while. And in this section, we're going to look at strings and string templates, ranges, a the operator, and type checks, and some casts. Okay, and in the final section, then we look at null safety and comments. So, to just firstly look at our strings and string templates, this will involve escape strings, raw strings, literals, and string literals and string templates. Okay, so just to give you the kind of the official spiel from the developer docs. Strings are represented by the type string. Strings are immutable. Elements of a string are characters that can be accessed by the index operation s square brackets I, and a string can be iterated over with a for loop. So just to go back to the strings are immutable for a second, that's at runtime. So basically, once we declare a string, obviously if we need to, the value can be changed, but the reference can't. It's to do with kind of multi-threading, which we will look at in later sections. But for the moment, a lot of the time you may end up just declaring it as val. So if we look at a little example here, just highlight there for you now for a second. Down here, we're inside again kind of an abbreviated function main there. We're saying val star is assigned to A, B, C, D. Simple, very basic string, 4 characters. And if you want, you can use your for loop to iterate over that string star. Like we saw in previous examples, in previous sections, we can say C for C in star, println C, and what we get is on each line A, B, C, and D. If we wanted it, we could get in at an individual. We could say S0 or S1. To give us the A or B, and so on and so forth. Okay, so and there's actually quite a lot you can do with strings, as we'll see now in later slides. There's 2 types of string literals. We have escaped strings that may have escaped characters in them, and basic raw strings that can contain new lines and arbitrary text. Now, to be honest, you may not use this quite a lot, but it's worth knowing and being aware of what you can do with strings. If in the eventuality that you need to do this kind of stuff, that you actually know you can. Okay, so we will look at both examples. So an escape string is very much like a Java string. So we see it there. We're saying val s is assigned our hello world, and you can see the /n there. Just gives a simple new line. Whereas a raw string is delimited by a triple quote. So again, we haven't seen that before. Contains no escaping and can contain new lines and any other characters. So if you see it there, just highlight it again. Here's our simple one. We've said val s, kind of hello world. That's generally the way most of us we will use it most of the time. But as I said, there could be situations where you may need to do something a little bit different. So you can actually do it like this. You can say val text with the triple quotes. So again, note at the start and at the finish, at the end, right? And we're using that pipe that we're kind of familiar from anyone who's done a little bit of Unix programming. We have it all on we can put it on separate lines. So we have a pipe, tell me and I forget. There's the rest of the text. We have a function call at the bottom there. Just to show you again, dot trim margin, which we'll talk about on the next slide, but that would be a raw string. Notice there's no /t's or n's or whatever. It's just our raw string, raw characters with some using the pipe there to just kind of format it a little bit better for us. Okay, so to talk a little bit more about that, how that would render on the screen, something like the following up here. So we have our there's our 4 lines of text rendered by this particular text here. This our declaration. Again, val is just text, and we would print text to the console. Just worth noting, you can remove leading white spaces with the trim margin. So if, for argument's sake, you read that in from the console or something, or from a file or whatever, and there was extra spaces in there, you can actually trim those using that trim margin function. A little bit more about string literals. By default, that pipe is used as a margin prefix, but you can choose another character and pass it as a parameter like so. So you can say, there again, just to kind of highlight it for you there. You can actually say trim margin and pass in whatever character you want. In this example, it's the greater than sign. So what we could say is something like val text, there's our raw string, and use the greater than sign. Tell me I forget, teach me and I remember, so on and so forth. Just that kind of quote from Benjamin Franklin there. And then trim the margin with that greater than, specifying the greater than sign as the margin prefix. And note the impact of the two spaces that we put between the greater than sign and the text. So it allows you, if you see it over here, see the little kind of space there. If there's a need to format your string a little bit differently, you can do that with a raw string as opposed to an escape string. Okay. To talk a little bit about string templates. So strings may contain template expressions, and we would have seen some of this before. But just here we are looking at it in a little bit more detail. These are pieces of code that are evaluated and whose results are concatenated into the string. A template expression starts with a $sign and consists of either a simple name, like so. Again, we'll just highlight there for you. So we're saying here val I, give it a value of 10. Then our val s is assigned a string. Note the string is just a double quote start and end. I is assigned, or the assigned operator there, $I, right? And so our I evaluates to our 10, to a value of 10, obviously, and then that, if we were to print that out, we would get I assigned 10 printed to the console. Or we can use an arbitrary expression in curly braces, and again we've seen a few examples of this in previous slides. Here we are looking at it in a little bit more detail. We have our val s, so again giving it an initial value of ABC, and then we say val star is assigned our double quotes $s.length. So there we are, just a simple expression, right? Is $curly brackets s.length. So there we have our expression within embedded inside the overall string. So it's like $s is just the ABC, so that's what we get there, just ABC. Whereas when we use the curly brackets, we actually invoke the function on, see it there? We invoke the function, or can I get the property, should I say, .length on our string s. So there's quite a significant difference between just saying something like $s or $s.length and $curly brackets s.length. So just be careful of that if you're embedding or using the $sign inside your string variables to get at other values and other properties, as they say. So the curly brackets will actually evaluate to an expression and carry out that. Like that could just as easy, we could have said s.length plus 10 or minus 5 or whatever, carry out a full expression inside those curly brackets, and that would, curly braces, sorry, should I say, and that would print that to the screen. Okay. Another little example there with regards to our string templates. So templates are supported both inside raw strings and inside escape strings. So here's, for a simple example, we're saying val an int is assigned a value of 10, and in val a string is assigned a value of an int is an int. We're saying $curly brackets an int with the escape with our \n. And we could say there, we could also have something like val text and then do all the rest of it again. We can print out a string, print out text there as well. Okay, so we can kind of mix and match there if we wish. Just looking at another example here, again in our kind of abridged function, our main, we can say there var a is assigned 1, Very simple. Val S1 is assigned A is $A. So what we get is our S1 string is A is 1. So the $A is evaluated to whatever the A happens to hold at the time, and that gets replaced. So the string then becomes A is 1. If we want to carry out some expression within the assignment of a string also, we can say something along these lines. We have our val S2, and we're saying dollar, curly brackets, s dot replace is comma was, close the curly brackets, but now is $A. And we can actually print that out to the screen. So we're carrying out, we're invoking a replace function on our string S1 and replacing is with was, and then printing out but now is whatever $A happens to be. Okay. So initially we get dollar, we're saying dollar our S1 gets printed out, A was 1, but now is 2. Okay, so where A was a value of 1, we replaced the text and we got but now is 2. Okay, so again, some nice functions that we can kind of use to just carry out some string manipulation. Okay, now to talk a little bit about ranges. Again, you may use this in very kind of specific circumstances, but worth knowing how to use them and how to use and ranges and apply them to different sets of data or whatever. So we'll look at the in operator just for a little bit. So we have a couple of examples here. We have a function main up the top there. We're saying val x is assigned 10, val y is assigned 9, and then a simple if statement. If x in, so again, just to show you there, if x in 1 dot dot y plus 1, so that's our kind of our we're using the in operator to check a range going from 1 up to whatever y plus 1 is. So in this example, obviously y plus 1 is 10. So if x in that 1 to 10 range, print to the console fits in the range, which is what we get. Likewise, if we can look at it in some other situations, we have here in our second example inside our function main, we have val list is assigned list of A, B, and C. So we're creating a little list, three values A, B, and C, and then we can check to see if -1 not in or 0 to list dot whatever the last index happens to be. Okay, so our last index again, or the indexes they will run from 0 again, same rules as them from Java. So our indexes would be 0, 1, and 2. So again, we would have that would actually be true, because if it's -1 is not in that range from 0 to 2, so we get that would print it to the console. That's what we get printed out. -1 is out of range, and then we can actually compare it against indices. We can say if our list dot size, so what's the size of our list? It's 3. So if 3 is not in the list dot indices and 0, which would be 0, 1, and 2, we get that printed into the screen also. So list size is out of a valid list of indices, ranges 2. So again, just different ways, different examples of how to use the in operator with different types of ranges. Okay, whereas the first example was just some basic numbers. The other examples, they're working with lists, working with indices from that particular list. So there's quite a lot of flexibility there that you have with the that in operator and what you can do with it. Okay. Iterating again, some another example there, working with a range. So we have our for x in 1 dot dot 5. So it's the dot dot operator is essentially signifies the particular range that you're wanting to look over. So here we're just going to print it out. Print x there up the top. So we get the simple 1, 2, 3, 4, 5. Here's an interesting thing we can do. We could do something similar in Java, but we'd have to use minuses and pluses and all the rest of it. So it's a little bit more kind of understandable than the way Kotlin are doing it. Here we have in our second example, we can say for x in 1 to 10 step 2. So if you want to jump up in steps of 2 or whatever it might be, it could be 3, 4, 5, whatever you want, we can print that out. So we would get in that example, we would have 1, 3, 5, 7 and 9 for the first bit. And then if we want to actually go the opposite way, we can say there for x in 9 down to 0, but in steps of 3. So we kind of work in the reverse order, print that out. We would start at 9, 6, 3 and 0. Okay, again, just different ways to use the in operator with particular ranges. Okay, so we have up the top iterating over a particular range, and then we have iterating over a progression. So it doesn't have to be sequential and in kind of single numbers. We can actually jump in steps of 2, we can go down in 3s, whatever you want. Okay, go up or down, whatever. To talk a little bit about type checks and casts, we would have touched on some of this in previous sections, but just to look at it in a little bit more detail here now. Here's an example of using our is and not is, or isn't, if you want to look at it that way, operators. So inside our function here, we assign a value or assign a string variable of type val there. So we give it a value, I am a string. We can then check to see if that variable is of a particular type. Is it of type string? So here we're saying if a string is a string class, has been declared as a string, we will print out to the screen there, console, sorry. String length is, and now we are looking at expression again, embedded expression, dollar or curly brackets, a string dot length. So that will evaluate to whatever the length of the string happens to be, which is 13. We can also do something like the following. We can look at the negative. We can say if a string not is a string or isn't a string, right? So if that is true, we'll print it out. Would be the same as saying not a string is string. So personal preference there would prevail. So you can decide whatever way you want to do. Otherwise, we can say string length is whatever. So first part there, that if will be true, we will get that printed. Second part, it's the else block we get executed. So again, we're getting the same println statement that the string length is 13. Okay, so just using our is and not is operators for comparing, in this example, a variable to is it of a particular type. And that's relevant in terms of smart casts. So in Java days, you might have to check to see was something a type of a class or maybe a subclass, and then you would have to cast it manually, and then that will give you access to methods that might be accessible in that particular subclass but may not be available in the parent class. All right, what we can do here is with our smart casts, and here's a simple example using an if statement. We have a function here called demo. So if we look at the function first, just highlight it there for you. Here's the overall function. Okay, we're passing in any type of a variable, so x of type any, and we're checking to see if x is a string, print it out, do println on the length of that string. Otherwise, print out the Java class property of it. Okay, so then if we look at how it's called up here, the first one we say demo I am a string, so we pass in a string variable. So again, obviously x is a string, and that would print it out. Otherwise, the second example there, we're saying demo 12, so as a number comes in. But otherwise, we just print out the class itself. So the example or the result is value of 13, again the length of the string. Otherwise, when it's a number, we get the java.lang.integer class reference being displayed out. But the interesting point here is that the number, it doesn't crash your application. If this was in Java, there would be a lot of extra checks you would have to do. And if we were trying to say compare x, which would be in this case a number, if it's a string, that we get a lot of errors. Whereas in Kotlin, it would automatically cast it. And then so we don't have to check to see is it a string first, then convert it to a string, and then go and execute or call the particular functions. Kotlin does it automatically for us, so we can just program ahead and do assume that it is the type we want it to be, and then call those the functions on it. So it's very kind of nice additions to the language there. Another example, we have using a SmartCast using a when. Examples are the kind of a version 2 of our demo function. So again, still taking in any type of variable, but we use a when instead. So here we have it here inside it. So we're saying when x, if it is an int, we'll print in that. If it's a string, we will print in x.length plus 1. And then if it's an integer array, we will print in x.sum. Okay, so there's quite a lot going on there in a very, very short, like 3 lines of code there. Okay, so if we look at what we're passing in, first call, just pass in an integer. So that will match with the first one. So we print it in 12 plus 1, prints it out there, we get our 13. If it's the second example, second call, passing in a string, so again we know this is 13 because we've been using it there throughout the slides. We then get it matches with the second clause in our when, so we print in the length plus 1, so again we get 14. Otherwise, the second example, we're passing in an integer array with 4 values, 1, 2, 3, and 4, and we say print in x.sum, so that will invoke the sum function on our integer array and display it to the user. But again, the point we're making here is that we as the developer don't have to do any checks, don't have in terms of being able to then convert it to an integer, convert it to a string, convert it to an integer array. It's all done automatically for us. So it removes that burden from the developer, hence a lot less lines of code to get the same job done. Okay, so again, very nice little feature. Some of the same references there again, so you can kind of check back on those if you want. I've kind of cut and paste the same references across the whole section. It all kind of covers the same stuff, but the official Kotlin language docs are where a lot of these examples will be taken from. So if you happen to be looking at those, you may see some familiar examples and so on and so forth. Other than that concludes this little section, and we will come back to the final part 1.4 of our kind of introductory syntax in the next section. So until then, goodbye. Hello everyone, and welcome to part 1.4 of our introduction to the Kotlin syntax. So to kind of wrap up this section, we'll be looking at talking a little bit about null safety and a little bit about comments and how to embed and place comments within your code. So first of all, we'll have a look at null and using nullable values and how we can check for null. So again, null safety in Kotlin, the type system distinguishes between references that can hold null, which are our nullable references, and those that cannot, are non-nullable references, or null references. The Kotlin compiler makes sure you don't by accident operate on a variable that is null. And again, this would have been quite common in Java, and hence that $1 billion mistake that it was labeled in the Java language. So to look at of how we can kind of get around that, right? How we deal with null safety and our non-null reference. So what we're familiar with already, and we've looked at plenty of examples to date, we can say something like var a and declare it as a type string, give it a value. Right, so a regular variable of type string cannot hold null. So if we then try to go ahead and say after we've declared it, even though we've declared it as var, which means we can change the value of it, if we try and say a is assigned null, we're going to get a syntax error. So the compiler will stop us there and then and say, sorry, you can't do it. But what if you need to, right? And we'll talk about that in a minute. But if we then try and call a method or access a property on variable a, right, because of that by default that it's not non-nullable, we're guaranteed not to cause that null pointer exception. Okay, so when we say val l is assigned a.length, we're guaranteed that a will have a value. So we can code kind of optimistically, and we can assume that L will have a value. We can go off and we can do something with L, and we know when we try and invoke that method, even on L again, it won't crash. We won't get that null pointer exception. Okay, but if there will be situations when we need, that's kind of restrictive, and there will be situations when we need to be able to store a null value in our variables, specifically kind of those string variables. Okay, so to allow nulls, and we have seen this before, just looking at it in more detail, we can declare a variable as nullable. So we write it, or it's written with the string question mark. So we can say something like, very similar to the last slide, we say var b, our full colon string, but we use the question mark, give it a value. We can then say something like b is assigned null. Okay, but if we go ahead and then say, like the previous slide, and try and invoke a function or access a property on that variable that potentially could be null, right? If we say val L is assigned b.length, we will get a syntax error there, because that variable b could be null at any particular point. So how do you get around that? How do you still allow us to have a variable to potentially hold a value of null, but then be able to go and actually use it? Okay, because Kotlin enforces those checks. So there are a couple of ways around this. Okay, so the first one, you can explicitly check if b is null and then handle the two options separately, very similar to what we would have done back in Java. Okay, so if we look at the example here, just to highlight it there for you. So what we're saying here is, using a simple if expression, we're saying val L is assigned if b is not null, return b.length. Otherwise, we'll just give it some default value, in this example of -1, and then we can continue on and use that L and check L to see if it's -1 or whatever. Okay, so that's one option. Okay, another option, hang on now, sorry. Another option, we can use the safe call operator. So we really haven't seen this to date, but this is again a nice kind of much more concise way to check this. So we can use the safe call operator question mark. So this returns in this example b.length if b is not null and null otherwise. So we can say b question mark dot length. So that's kind of saying, look, yeah, if b happens to hold has been instantiated, it does hold a value, return the length. Otherwise, assign that the null value to what, or to return, should I say, just return that null value. Okay. Third option, again, for all the null pointer lovers out there, right? You can use the full call, or the double kind of what would you call it, exclamation marks, the null assertion operator. Okay, so this forces a call to our method and will return a non-null value of b, or actually go and throw a null pointer exception if b happens to be null. So again, you're kind of going full circle there. You're kind of going back to the Java days, but you're explicitly asking for that exception to be thrown. So again, we're just saying use that sparingly. I would prefer this approach. Just use your b full or b or whatever the variable is, question mark, and then invoke the property. So it'll either return the object itself or return a null. Okay. So we can put that is available to us, the null assertion operator, two full colons there. Okay, so if you happen to come across it in any kind of examples that you're looking up online or whatever, that's what that means. Okay. The Elvis operator, so when we have a nullable reference b, we can say if b is not null, use it, otherwise use some non-null value x. So compare it to the previous example, so just to look at it again. So here, very similar to our Java days. Okay, we're saying there, here's our val L. So declaring it of type int, so we're explicitly saying what it is, and then we're using our expression as we saw in a few slides previous there. If b is not null, return b.length, otherwise return that default value -1. But we can use the Elvis operator if we want. So that can be a lot more concise. So we can do something like this. Along with the complete if expression, this can be expressed with the Elvis operator, written like so. So we could have there now, our val L is assigned, there's our b question mark dot length, right? Elvis operator -1. So again, a lot tidier, a lot neater. So if the expression to the left of the Elvis operator is not null, it'll return it. Otherwise, it'll return the expression to the right. So again, it's a very concise, very neat kind of if-else. Okay, it's referred to as the Elvis operator in Kotlin. Okay. Nullable returns, right? So if you have a function that potentially could return a null value, you can identify that also. So a reference must be explicitly marked as nullable using our question mark when a null value is possible. So in this example here, we're just saying function parseInt takes a string but returns potentially a nullable value. So we're hoping it'll be an integer, it'll hold a value, but it may not, it may be null. This is how we identify it, that it potentially could be null. So this will return null if the return value does not hold a particular integer. Okay. And to finally just talk a little bit about comments, this is very similar to comments in Java. So a lot of this, it'll kind of, as I said, look familiar to you. So just like Java and JavaScript, Kotlin supports end of line and block comments. So we can have our symbol or single a forward slash, double forward slash for kind of a one-liner, or if you want to do it in a block, we can have our forward slash and the asterisks, do what we say, what we want to say, and then close it off with the asterisks and the closing slash. Okay. Unlike Java, block comments in Kotlin can be nested. Okay, so you can actually put ones inside, put comments inside other comments. So in Kotlin, it's kdoc, which is the same, which is equivalent to your Java doc from Java. So if you can see it here, look, we can have our all our want to use our asterisks is inside it just to see it there. Hang on, just show you. See, we can use our asterisks inside as well, inside the comments, the block comment there. We can look, we have our @param, our @property, and @constructor, so it'll pick all those up. We can again put our comments, block comments inside. So in this example here, just we can add the members to this group, so @return, whatever it's going to be. So again, very similar to a Java doc. Okay. We have a full set of full set of tags here. So we have our look @param, @return, @property, common there, @throws, @exception. Hopefully you don't get too many of those. @author, okay, @suppress if you want. So you can for more information there, you can just visit the official docs again, kotlinlang.org there. Okay. But again, if you're used to using Java doc, it's very, very similar. So you can just kind of continue on with what you've been doing so far. Okay. So that there's our again to say our same references. Okay, same as before. So that concludes our overall part 1 section. So again, just to briefly go back to what we looked at in total. So we have our types, variables, functions, control flow, strings and templates, ranges, our type checks, a little bit about null safety, and I just finished off there with comments. So in part 2, I have that kind of broken into smaller sections as well, just to make it easier to manage and view if you want to view them separately. And they will start looking at more of the kind of, as I said, the nuts and bolts of the language itself. So we'll be looking at our classes, creating different kind of classes specifically just for information data classes. We'll look a little bit on interfaces, creating those classes, constructors, a lot of the same concepts that you would be familiar with from Java, but just done in a much more concise, much tidier way. Okay, so that's what we will look at in the coming sections. Okay, so until then, goodbye. Hello everyone, and welcome to our Introduction to Kotlin Syntax Part 2. Okay, so we've kind of wrapped up some of the basics in the previous parts, part 1.1 to 1.4, which is there. There's our list from our kind of what we covered in part 1. So in our part 2, the overall sections will cover the following: writing classes, so we'll be looking at properties versus fields, and there'll be functions in there as well. Data classes, collections, and arguments. So we'll be familiar with some of those from Java, but there's obviously a lot of differences as well. So today in this section, I want to talk about writing classes and specifically data classes. So, and we will see this now in our both in our Kotlin, our Placemark console version, and in the Android version as well. So they'll be introduced quite early. Okay. So to begin with, just talking about properties and fields when writing classes. In Kotlin, classes don't have explicit fields to refer to as properties. And we've got our var properties and we've got our val properties. So var properties are mutable, so similar to when we're declaring our simple variables, that we can change those values, whereas val properties cannot be changed. Okay. When writing classes, again, terminology is the same from Java, or particular constructors. So a class in Kotlin can have a primary constructor and one or more secondary constructors. Now, most of the time, that primary constructor will do it, but we do have the flexibility if we need to have other constructors to complement the original one, the main primary one. The primary constructor is part of the class header, which is very different to Java, right? And it goes after the class name, like so. So if you can see here, we have our class person. We're saying we have a class person that we're going to declare, right? We can explicitly say constructor. In this example here, we just have a simple first name property of type string that would be representing the person class. More often than not, we can say something like the following. We can say class person. Here we are excluding or leaving out the constructor, explicit constructor keyword. So we can say class person, their first name is of type string, last name of type string. But what's most commonly used is the following. We can say class person and then the type of declaration, the modifier. In this example, we're saying val first name of type string and then comma val last name of type string. So that's kind of what we will probably use most often. Okay. An example of using our primary constructor. So we can say something along the lines, here we see an example inside our function main, right? We can say val person is assigned person. We have inside our brackets, inside our constructor, we're passing in our two values for the properties, Joe and soap. And notice there's no new keyword. If this is a big change from the Java world, there's no need to use the new keyword. We can just go straight to the class name and then a call to the constructor similar to what you would have done in Java. If we want, simple example there, we can print them out. We can access those properties exactly the same way as you would in Java. So here we are using a string expression. We have a first name getting printed out, or surname. To reference the first name property, we say that person object. We said val person, so person.first name, person.last name. Again, inside our expression. So very similar to how we would have done it in Java. And you can see there the final little screenshot. This is what actually gets printed out to the user. Okay. Again, so that's our primary constructor. If we want, we can have a little init block there, so we'll talk a little bit about that. So the primary constructor cannot contain any code. That's kind of important. We could have done something like a little print statement inside our constructor in our Java world. Not so in Kotlin, but we do obviously have another way to do it. So what we use is this thing called an init block. Okay, so here we have our class person. We're now saying underscore, or passing in variables, or the variables to be assigned to the properties. We're saying underscore first name of type string, underscore last name of type string, but we're also giving them a value. This is a nice little thing we can do in Kotlin as well, and we'll talk about that in a little bit more detail. Okay. So inside our class, here we are declaring our two properties, first name and last name, both of type val, assigning them the variables passed in, and then we can actually print them out inside that init block. So if we want some initial code, pardon the pun, to be executed, we place it inside that init block, and that will be automatically executed. We don't have to call, we don't have to say .init, and we don't have to put it in some other function. We can wrap it up in that init block, and when our person object is created, that init block will be executed. And here in that example, it'll just, similar to the last time, it'll just print out that first name and last name. So in the previous example, where we were getting at first name and last name outside of the class, so we would have had to access those properties through the object, that person object. Here we're getting at them, doing the same thing, but we're actually getting at them inside the class. Okay, so we just say dollar first name, dollar last name. We can access those properties directly. Okay, just to continue on there a little bit, some other examples. There's our class person, same as before. Here we are now using some examples, right? And this is quite nice. We can initially say there, just again, a little example here. So what we have is we have three person objects getting created. Person 1, person 2, person 3. Person 1, we're following the full kind of qualified first name and last name properties. We're passing in Joe and Soap. But if you notice, in the second one here, we're only passing in Jack. And in the third one, we're not passing in anything at all. And that's fine because of how we declared our constructor class to begin with, right? And we initially were giving default values. We'll cover this in more detail later on, but for the moment, that's what we're doing there. We're assigning default values to both first name and last name. Okay, so if they aren't assigned a value, they get those default values. So what we end up with, we have our, if you note there, just a little comment, variable parameters are allowed in the primary constructor as the values are defaulted. Okay, so if we look at what actually gets printed out to the screen, so for the first one there, here's our person 1. So we passed in Joe and Soap. There we get Joe and Soap printed out. Whereas in the next one, we just passed in Jack. So as the first parameter, so that matches. So here we have our first name and last name. But the last name defaults to the unknown last name that we assigned over here in the constructor. And if we actually leave it blank altogether and just create a person object with no parameters been passed in, no values, both first name and last name get those default values. So again, nice little feature within Kotlin that we can assign those default values and then we can mix and match. So we don't have to, every time we create the object, have to pass in properties that match exactly the parameter list. We can actually decide what we want to pass in once, of course, we have assigned default values to begin with. Okay. Now, if we want a secondary constructor, now we have to use that constructor keyword. So the secondary constructor is prefixed with the keyword constructor. Again, they're not very common in Kotlin, but you can do it. So there may be situations where you want to have a couple of different ways to create your objects, like you could have done back in Java. Again, if you want to find out a little bit more about it, you can have a look at the official docs there. Just in this example here, we're for argument's sake, when we create a class person, we're saying there we're passing in the constructor, we're passing in another person object, we're calling a parent, and then that we're assuming here that parent object has within it possibly a list called children, which allows us to add another person to that list. So we're kind of we'd have our children.add, and again there's that this reference. So we're again, that's from similar to Java, which would add this person itself to that parent list of children. Okay, but again, not that common, but look, if you need to, you can. Okay. In terms of getters and setters, okay, so in Kotlin, the getters for val and var, and the setters just for var, right? If you think about it, you can only set a var, right? Are optional and are auto-generated if you do not create them in your program. Now this is getting into the specifics of those setters and getters. You don't really need to worry too much about this, but if you want to, this is what you would get. Okay, if we say for argument's sake here, right, here we are declaring our class person, right, and we are specifying a single property in this example, just name, of type string, giving it a default value, right? What we get supplied for us, okay, are a get function, right, and a set function. And we have this kind of inbuilt field property, okay, and that that kind of matches the property itself. So here, this all again is all generated automatically behind the scenes for us. You can override these if you want to. It's not very common, but you can if you need to, right? So this kind of field property would get replaced in the instance by, in this example here, name. So if we wanted to get, we're essentially, the get would return, in this example, name. Here it would have name updated with the value that's passed in. Again, not very common, but is available for you to override those getters and setters if you want to. Okay, but as I say, by default, these properties up here, when we say var name, that's public, so we can get directly at name without having to go through our getters and our setters. Okay, just to look at how we can use that stuff again. So when you instantiate our object of type person in this example here and initialize the name property, it is passed to the setters, parameters, values, and sets the field to value, like I was kind of just discussing there in the previous example. So down here, previous slide, sorry. So what we have is, here we are saying our val person, again, default constructor, okay, so that the string would get the default name, but we can say person.name is assigned a value of Jack because it's a var. If you remember here, we declared it here as a var, so we can change the name property and then we can print it out, right? But behind the scenes, that getter and setters are getting called. So in this here, the setter would be getting called because we're updating the name, and in this call here, when we reference person.name, the getter would be automatically getting invoked. Okay, and again, that's when we print it out, simple Jack gets printed to the console. Okay, a little bit more about it there. If, as I said, if you need to override, that's your override it yourself. So in this example here, when we'll be adding a validation to your setter, so you could say something like this. We have, if you look at this example here, we're saying our val person, but look, we're saying person name is assigned an empty string, right? And then we're trying to print it out. So maybe we want to check for that. We want to check for that empty string. So we can, in our class declaration, do something like this. So we would say our var name, but if we're going to override this, we have to do it for all of them. We can't just kind of pick and choose. So here will be our get, which would again return the name property. So field would be replaced by name when our class would be getting kind of generated. Here we are, here's our set, but we're overriding our set ourselves as the developer, right? And we're saying the field property, I want to assign it an if expression. So if the value, so that's the one that's getting passed in, it's this here, if that happens to equal the empty string, which was what was set there, right, we're going to return an unknown value. Otherwise, just set the value like would happen by default. Okay, so that's how we can, if we need to, build in some very basic validation. So in the overall example, in our little function here, our little program, when we run it, because we did try to set it to the empty string and then try and print it out, we validate and we would update it to unknown, and that's what gets printed to the screen. Okay. To look at it, if we want to add another property, we can say something like this. So each one gets, it's like it's all blocked together. Each one gets its own little setters and getters. So here, look, here's our var name, right, as before. So there's the get for that, the set for that, right? Maybe you're wondering, how do we identify one field from another field? Well, this is how it's done. So we might come up with another variable, so it's all kind of grouped together. Be careful to put these on a separate line. That's the way that's the way it's interpreted. So we need to put these on separate lines. Okay, so here we are now. We're adding another property, calling it an ID, declaring it of type integer, giving it a default value of 10001. Right, there's our getter, and there's the individual setter. Again, notice look, field and field, right? But that field is associated with this ID, and that field is also this ID. So that's how we separate out, and that's how Kotlin kind of identifies the different properties, but still uses the same keyword field for kind of replicating or replacing, sorry, should I say, when that class is instantiated. Okay. Just to talk a little bit about field, that field and value properties. So you might have noticed two strange identifiers in all the getters and setters, that field and value. So we use value as the name of the setter parameter. This is the default convention in Kotlin, but you're free to use any other name if you want. The value parameter contains the value that a property is assigned to. So for example, when you write person.name is assigned Jack, the value parameter contains the assigned value Jack. So if we're using field, right, that helps you refer to the property inside the getter and setter methods. This is required because if you use the property directly inside the getter or setter, then you run into a recursive call which will generate a Stack Overflow. So you couldn't actually call it ID inside it, or you couldn't call it name inside it, because then you get that recursion and you will end up with that Stack Overflow error. So that's why this kind of generic word field is used, and then as Kotlin itself will replace each pardon the pun field with the property that it has been declared by. So again, in the previous example up here, just to show you again, up here field gets replaced with name, down here gets replaced with ID, or whatever one you want. And as we say, you could pass in your own name there as well, whatever you want to call it. Might start getting a little bit confusing. So I would kind of recommend sticking with what Kotlin gives you. Okay. Now, to talk a little bit about data classes. Now, these are going to be very relevant in all our labs, both on the console side and on the Android side, right? And it's essentially just for storing data. So this is what we're kind of going to start with first. Okay. So we frequently create classes whose main purpose is just to hold data. In such a class, some standard functionality and utility functions are often mechanically derivable from the data. In Kotlin, excuse me, this is called a data class and is marked as data. So the keyword, the modifier data is used. The compiler automatically generates methods such as equals, a hash code, a toString, a copy from that primary constructor. So that all gets generated behind the scenes the minute you prefix your class declaration with that keyword data, which is really, really handy. It's a very nice feature within Kotlin. So in this example here, we take our class person, which is what we used before. We prefix it with that single word, single keyword, single modifier data. All of a sudden, our class person gets all those other methods by default, and then is kind of optimized for storage. And we can compare one person object against another. The copy method becomes important, especially when we're storing those objects in lists, and we'll talk a little bit more about that when we get to it. Okay, but again, essentially just using that one modifier, that keyword data, converts, I suppose, that simple basic class into a data class, which we then use for storing our information. Okay. To talk a little bit more about the requirements for that, right? The primary constructor must have at least one parameter. So you can't actually do an empty one. And if you think about it, the whole reason behind a data class is to store data. So if you're not actually passing anything in, it's probably not much use in the first place. Okay. Second requirement there, the parameters of the primary constructor must be marked as either var or val. You have to explicitly say whether it's modifiable or not. The class cannot be open, abstract, inner, or sealed. They're all other types of classes that we can create, and again, we will look at those in later sections. And finally there, the class may extend other classes or implement interfaces, and we may look at that now again in later versions and iterations of our case study placemark. Okay, so they're just the kind of the main requirements. Most of what we will do is what you're looking at there. We will take our class, we will stick data at the front of it and give it some properties, maybe give it some default values, as we'll see in examples, and that's probably as much as we need to do. Okay. Where we can use this, so if you look at our copy and toString examples, okay, so there's our same declaration up the top, our data class person with two properties, first name and last name. How we can use them, okay, so just I'll highlight it there for you. Here we are saying val person2 is assigned person1 dot copy, all right, and then we're saying first name is assigned Martin. So this copy is quite important, and this would have been issues that would have cropped up in Java as well in terms of this pass by value, pass by reference. Okay, we want to make sure that we actually create a true copy of the object, so that if we just assigned person2 or person1 to person2, it'll actually reference the same data. So if we change one, it will have a knock-on effect and automatically change the other. Whereas when we say person1.copy, we're actually creating a true copy of person1, and in this example here, we're changing or assigning, should I say, first name a value of Martin. So we get to change that first name, and it's a totally separate person object. And that's kind of that is important. It's an important point to stress. And we will come back to this in due course when we start working with lists of objects, or in this case maybe lists of persons. Okay, so initially we would have, just see it there, we would have declared a person, say val person, person1, sorry, John Murphy. Okay, here we are person2. We're copying person1, but it's going to be a true copy. So when we print out person1 and person2, what we get is, if you see it down here, person1 is that John Murphy, which is what we'd expect, but our person2, we've actually updated the first name, okay, which is a nice thing to be able to do there in terms of using .copy. So we're actually copying and updating, just here, person1.copy, and updating or assigning a new value to that first name. Okay, and that is important when it comes to dealing with lists of objects, that we don't have these kind of unintentional knock-on effects where we change one and there's a ripple effect because it's actually referencing the same object. Okay, here's a bigger example. Here we are creating 3 different person objects. Okay, so person1, person2, person3. First one there, default values, prop values, John and Murphy. Here we are then just doing a straight copy of that person1 into person2, but it's still a separate copy. And then we're doing the same with person3. It's also a copy of person1 where we change the first name like we did in the last slide. We then print out the hash code. So there's just, we're calling the hash code of each. So you can see it here. Up here, look, we have, you can see it there. Our person1 and person2, because the hash code, so when we apply, it's like it's hashing it, if you're familiar with that term, it's ways of kind of optimizing how we store data and allow us to retrieve it quickly. So you can have a kind of a unique hash code based on the data. So if you notice there, see the hash code is actually the same because the data is the same, John Murphy. So our person1 is still, even though it's a separate, unique object, the data is still the same. So hence the hash code is still the same. Whereas with the third one, person3, still a copy of the first one, but we've changed first name, so we get a different hash code. Okay, and then we can actually invoke some of the other methods. There's a big if else block, so we're checking to see if our person1 equals person2. So again, the equals again is based on the data. Or what the value of what's stored inside it. So again, here we are, look, person1 is equal to person2 because they're actually the same data, whereas here we're saying person1 we compare to person3, they're not equal because we would have changed the first name. Okay, so just be clear that the dot equals compares what is inside the objects, not the actual kind of object references themselves. Okay. Some references, and we will kind of come back to some of these in later sets of slides. Look, we have inheritance. Again, all these terms are if you're coming from a Java background, would all be very familiar with you. We will see these references in later slides again. So we will be looking and talking about inheritance and talking about interfaces, collections. Collections will crop up a lot. So again, if you've done Java and you know about your array list and your linked list, a lot of it would be familiar to you. And in the second, so I suppose just a quick recap there again. So in this section, all we looked at was just writing those simple classes and how we go create data classes. And again, these data classes will form a big part of the overall module, and specifically the case studies. Okay, so in the next sections, we will look at more specifically arrays and collections. So be able to store simple classes and data classes in collections of objects, array lists, linked lists. And then we look at some of the more kind of more specific features of the language and how we can use the in operator and use lambdas to process and navigate through these collections. And finally, we'll finish off with their just a little bit about arguments and default and named. We've touched on them briefly. We will look at it in a bit more detail in that final section. Okay, so other than that, that wraps up that section. So thanks for listening, and goodbye. Hello everyone, and welcome to our walkthrough of version 2 of our Placemark console application. So again, similar to the last walkthrough, we'll have a quick look at the code and specifically highlight where certain features crop up in our application. Okay, so if we look at our features that we covered from part 1, so again, there's still basic types, there's variables, there's still strings and templates, there's a bit of null safety going on. But also we have our data classes, and now we kind of haven't really looked at arrays and collections yet. So I'll briefly touch on them in this walkthrough, but they are very similar to what you would have done in Java. So hopefully it won't be too confusing for you. Okay. So to begin with, we'll look at our project structure. It's still fairly basic. Okay, we now have two packages. So we had our initial main with our main.kt file in there, right? And we now have a model, our Placemark model. And again, you will see this again in the Android version of Placemark. So wherever possible, I'm going to try and keep in line with what Eamon will be, my colleague Eamon will be covering, which is in the Android version. Okay. We have in our main.kt again, just some additions. You can see there we have it's still a source file, one Kotlin source file, but we have added in a couple of extra functions. We now have there's a function get IDs, a function search, there's a function dummy data. We will look at those later on. What's main point to note is, and we just highlight this here, is our array list of placemarks. We're using that placemark model. Okay, so we're declaring an array list called placemarks, and it's going to hold our our placemark model objects. That's what that's going to hold, and we will look at that now next. Okay, so here's our placemark model, and this is a class. So be careful when you're in the lab, when you're creating this, it's a class you want to create, not a file. Okay, it's a class this time. Inside is very basic, as we would have covered in the section on our data classes. We're saying data class, placemark model, 3 parameters, all vars, an ID, a title, and a description. And we're explicitly giving them some types. So for our ID, we're saying it's a long, and just giving it kind of a default value. Okay, in this case, just 3. And just kind of empty strings, just to give it some default values. Okay, and again, that's inside our package models also. Okay, and that would be exactly the same as what you will see in the Android version as well. So a lot of the classes that we will cover in the console version, they will crop up again in the Android version. Okay, so to look at a bit more detail about where those data classes are used within our version 2 of our Placemark console application. Okay, so again, note the data class declaration as covered in the lecture slides. optimized for storing only data, so we get that dot equals, that copy functions supplied for us. And we will use this class for modeling a placemark object. So to begin with, in our console version, a placemark will essentially just represent, will just hold a title, a description, and to be able to uniquely identify a placemark and go off and be able to find them, we're going to give it an ID as well. Okay, so that's what the placemark model represents. Okay. We've got our 3 arguments. Again, they're named. Again, ID, title, and description with those default values. How we create them is like so. If we want to create an individual placemark, we can say something like var a placemark is assigned just placemark model. So by doing this, using our default constructor, we will get those values just assigned automatically. Or as we saw in our main.kt, we can create a list. Sorry, try that again there. Yep. We can create a list of those objects. Okay, or those placemark model objects. So what we will probably see is we will create one of these. We will then get information from the user, assign those, and then copy or store an individual placemark inside our list of placemarks, or we will add that placemark to our list of placemarks. Okay, and that's kind of the general approach we'll be taking. In terms of, sorry about that now. In terms of functions and control flow, where that crops up, we've seen this already. We'll just look at it in more detail again in our version 2. Okay, so because we have more functions in our app to implement our CRUD features, so we'll just look at a couple here to kind of give you an idea of what we're doing, and you will then be taken through the rest of them in the actual lab itself for implementing. The labs follow the same procedure. We'll basically give you a lot of the code. It'll be more about you piecing together the application and understanding how it works, as opposed to trying to write code from scratch. So we will look at some of the functions here, and then you'll see the rest of them in the lab. Okay. So if we look at our add placemark function, or essentially our create from our CRUD, right? We first of all see it up here. We're just so inside our add placemark, we're initially creating a placemark model object, calling it a placemark. We then prompt the user. We then prompt the user for the information. So we're saying enter a title, enter a description. If you notice there, we're actually using our null assertion. Okay, just in case from our read line, it's basically a function that will read a line of input data from the console. So if the user happens to hit return without entering anything, that would be null. So we need to just identify that yes, a null value could be returned, but we will actually check that later on. We'll see how it works. Okay, so we're doing the same for both title and description. And notice we're assigning that directly to our placemark. So we're saying a placemark dot title is assigned the return value of read line here. We're doing the same for the description, and then we do some simple validation on it. Sorry, just highlight there again for you. Okay, so we're checking to see if our title is not empty and our description is not empty. We update the ID. So this is very basic. We're not actually creating. We have no kind of auto increment number just yet. So we're just basically incrementing the ID of the placemark. And if you notice here, we're saying our placemark dot add. This is important. A placemark dot copy. So we're adding a copy of placemark. So that if we just added placemark, any changes that were made to this placemark here inside this function would actually be replicated and would be seen inside our list of placemarks, which is what we don't want. So we need to create a true copy. Hence, we can call the .copy function of that placemark just to add it. We're using our logger. You can see it there just to kind of confirm yes that the logger was added. Otherwise, we just prompt the user, sorry, placemark not added. Okay, so some basic validation going on there. Okay. In terms of listing them off, very, very straightforward. We can say something like this. We can have our inside our list place marks, just some simple print lines, giving some information to the user. We can say there place marks dot for each. So we saw this previously. We can say dot for each. We can log our dot info, and there's our dollar, the expression IT. So that would get at each element in each place mark element, each place mark object inside place marks, and display to the screen. So if we see down here, if the program is actually running down here, for argument's sake, the user chooses list, option 3. We display our logger. There it is. There's our kind of dummy data. So again, just to speed things up, there's a function there with some dummy data in it to just initially add these 3 separate objects, these 3 place mark objects to the list. So when we choose to print them out, the it reference refers to each instance. So it'll run through our list of place marks and print it out on a separate line, which is quite nice. Okay. If our update, which is a little bit more complicated. So first of all, we need to go find a place mark. So we have some helper functions there. We first of all, again, this is just my own kind of personal preference, and first of all, just list the place mark, so that because we need the ID, I'm just going to display it back to the user, because we can't expect the user to remember every ID. Okay. We then go off using our get ID to prompt the user for the ID they want to search. So we store that in our search ID, which we then pass to our search function, which will return a reference, and that's important, will return a reference to a place mark inside our list. Okay. We're declaring then some local variables there, temp title, temp description, again, allowing them to be null, because there is always a possibility that the user may press return when prompted to enter a title, and it could be empty. So we need to kind of just keep track of that. Potentially it could be null coming back. So once we make sure that we have found a place mark, so a place mark is not null, otherwise we have our else block down here, just telling the user place mark wasn't updated. So if we have found an existing place mark based on the ID that the user has typed in, we then ask the user for a new title and read it in via read line, ask them for a new description, a read line and read it in, and then we do some similar validation on that also. So we check to see if that temp title is not null or empty and our temp description is not null or empty. We update the place mark title and the place mark description. Notice we're not referencing the collection. It's all done through app place mark, because that we've returned in our search, we've returned a reference to that same object inside the list. So here, this is when it's changed here, it's actually updated inside the list. So we don't need to go near the list at all. Again, it's quite nice. Again, just some extra information, just telling the user what they've updated to. So we print you've updated the title, the description, and we log it then as well. So we just kind of $at place mark. Okay. So that's we'll be seeing that again in the lab. Okay. Our helper functions. So here's our get ID. We have two. There's our get ID and our search. So if we look at just the get ID for the moment, we again have a nullable string ID in case again the user could press return, could hit it by mistake, may not enter a value, may enter a letter for that matter. So we ask the user to enter it using our read line again, check to make sure that the ID is not null, right, and it's not empty, right, and then we can actually convert this to its long equivalent. Otherwise we want to return a -9. Okay. So if it's not a number, right, we can return -9, or sorry, we'll assign it search ID to -9, and then otherwise we just return it back to where we need it. Okay, so get ID will, as you see it there, just returning along. We also then have our search. Okay, we'll look at this in a bit more detail now in the later slides with our lambdas and what have you. But the search takes a simple ID type long, but returns a placemark model. Again, potentially nullable in case the ID doesn't that we're looking for doesn't exist within our list. So we need to make sure that that is allowed to be nullable and returned as a null, right? And we have our found placemark, right? Of type placemark is assigned, and here we have, it's very, very concise what's going on here. There's quite a lot happening in the background here, and it's all done in one line of code. We're saying here placemarks.find, so any collection class within Kotlin has a built-in find function that will go off and look for and search or find a object based on a certain condition. So for us, we're saying here, and again, this is kind of like the IT reference. Here we're using this is kind of like an anonymous function. It's kind of like in JavaScript, okay? Or this is actually a function call here, right? But notice there's no parameters getting passed in per se. It's all done inside using lambdas and higher order expressions, as we'll talk about in a minute. So we're looking to see if the object if the object, referring to as P, inside our list, if that ID matches the ID that was passed in, right, which is back over here, so there's our ID there. So that ID is equivalent to this ID here. If that matches, that's what gets assigned to our found placemark, which is then returned, like so. Okay, so that's a very concise search of your list based on an ID. Okay, and we will see these higher order functions later on. There's quite a lot of them available with the collection class. Okay, collection classes, sorry. Okay, so to talk a little bit about those are arrays and collections in our version 2. Okay, so the val variable placemarks is declared as an array list of placemark model objects. So again, virtually equivalent to what you would have seen in Java, just that the syntax is slightly different. The end result is the same. We can add to this collection like so. So we would have seen examples are the same as the collection Java collection classes, because that's essentially what they are, right? We're saying placemarks.add. Here we are kind of hard coding in a value, our placemark model, just giving it a default ID and some properties, a title and a description. Or, as we saw in our add, where we've gotten information from the user, we can say our placemarks.add and then that local object that we created. But again, be sure we call the .copy, that we pass in a copy of the object. Again, so note the use of the .copy. This ensures a copy is stored, not the actual object, to avoid unexpected changes to our collection data. Okay, so wherever possible, try and make sure you do that. Okay, a little bit about lambdas. We'll cover this in more detail in later slides, but just to briefly touch on it now as it's in the lab. Okay, so here the collections find function is a higher order function, which means we can assign it as a parameter and pass anonymous functions to it. And we're using lambda expressions in this instance here, so you can see it there now. So we can actually we have our placemarks.find, right? If we were to try and expand that out, try and think of it as a find, open brackets, we'll be passing in our particular object that we're the ID we're looking for. We're then getting in at the ID property of the object and comparing that to each element inside the list, which is very, very nice. Okay, and again, that's all done in just a single line of code. Okay, and we kind of come back to these now later on in later examples, and you'll see a lot of them on the Android side of things as well. Okay, there's our references, very similar as before, and that is the kind of the code walkthrough on version 2, and we will come back to then some more on the collections and on those lambdas and default arguments in the next section. Okay, so thanks for listening, and goodbye.